Hey guys, welcome back. Let's do the next few problems here. So we just finished with converting fractions into decimals, and these were kind of simpler because I can use the place values to do that. Looking at these next two though, I have 1 over 8. Now, looking at this, there is no eighths place value. Looking at this decimal that I started with, there's no eighths place value, and there's no way to turn an 8 into a place value number. I can't turn it into a tenths, a hundredths, a thousandth, thousandths. So when that's the case, instead of doing these place values, I had to treat the fraction like a division problem. Every single fraction is a division problem. 1 over 8 is the exact same as 1 divided by 8. Actually, let me write that above so I have a little bit more room to work. Yeah, so 1 over 8 is the same as 1 divided by 8. Now, I'm going to treat this as a division problem and set up my long division. So the first number, or top dog, always goes in the doghouse, right? 1 is the top dog, it goes in the doghouse. First number, the doghouse. Either way, you can remember, okay? 8 goes on the outside. It's the divisor here. So now I'm going to start dividing. 8 into 1, that goes 0. Now look, I have no more numbers. I can't do anything. When this happens, I'm going to add a decimal right here because I want this 1 to stay a 1, and then I can add as many zeros afterward. Imagine if I forgot the decimal. That would be 10, and then 100, and then 1,000, and then 10,000. That decimal is important because it keeps that 1 a 1. So 8 into 1, that goes 0. I'll bring my decimal up here. Now 8 into 10. Well, that goes in there once. Great. 8 times 1 is 8. I subtract 10 minus 8 gives me 2. I'll bring down the 0. 8 into 20, that goes twice. 8 times 2 is 16. I'll subtract and get 4. I'll bring down another 0. 8 into 40, that goes 5. 8 times 5 is 40. Subtract and get 0. Hey, I either end up with a 0 as a remainder or a repeating number. Luckily, I ended up with a 0 as a remainder. So this, 0.125, is my final answer. And you know what's great? If you had treated these like division problems, just like I did this one, you get the same exact answer. Let's look at this first one. If I treated this first one like a division problem, let's say I forgot about the place values and all I knew was that all fractions were division problems. Let's say that's all I knew. So this would be 9 over 10 is the same as 9 divided by 10. Top dog gets the doghouse. Set up my division. So now 10 into 9, that goes 0. But look, I'll add a decimal and an endless amount of zeros until I get the number that I need. So 10 into 9 goes 0. Bring the decimal up. But 10 into 90, well, 10 into 90 goes 10, 20, 30, 40, 50, 9 times. 10 times 9 is 90. I subtract and get 0. I end up with a 0, no remainder. So look, I end up with 0.9. And hey, look, it's the same exact answer. Same thing would work over here. Negative 2 into 20. I could keep 20. Actually, let me rewrite it. So I got negative 2 divided by 20. So top dog in the doghouse, 20 into 2. And then 20 into 2, that goes 0 times. I'll add a decimal and as many zeros as I need. 20 into 20, however, bring that decimal up. 20 into 20 goes once. 20 times 1 is 20. Subtract and get 0. Now, looking at this, I don't need to keep bringing zeros down. 0.1. That's the same thing as I have up here. Now, this is a negative. That's because this should be negative 2 because that 2 is a negative. So, negative 0.1 is what I'm looking for there. Just what I got up here. Remember, I can add as many zeros on the end of this as I want, and the number doesn't change. So, negative 0.10 is the same as negative 0.1. Either way. All right? So, let's look at this last one, negative 5 over 11. There's no way to turn this 11 into an easy place value number, so I'm going to have to treat it like a division problem. Top dog is the doghouse, negative 5. 5 in the doghouse. Now, I never usually put the negative in the division box. I usually do it over here. That way I just don't forget it. All right? Sometimes when it's in the division box, that kind of confuses me. So I'm just going to keep it in my answer to make sure I don't forget about it. So now, 11, that goes on the outside. 11 into 5, that goes 0. If that's the case, I'll add a decimal. As many zeros as I need on the outside. Let me bring that decimal up so I don't forget about it in my answer. So now 11 into 5, that goes 0. But 11 into 50, that goes 11, 22, 30, 34. That goes 4 times. 11 times 4 is 44. I'll subtract and get 6. Bring down to 0. 11 into 60, that goes 5 times. 11 times 5, that's 55. Subtract and get 5. I'll bring down to 0. 11 into 50, that goes 4 times. 11 times 4 is 40. 11 times 4 is 44. My mistake. Subtracting and get 6. Bring down to 0. 11 into 60, that goes 5. Hey, I'm starting to see a pattern here. The 4, 5 is repeating. When this happens, I'm going to write this as my answer, negative 0.45. And I'm not going to write all these extra 4 5s because they would keep on going forever. Instead, whatever is repeating gets a line put over the top of it. So now this is negative 0.45 with the line over the 4 and the 5 because they're both repeating. All right. Let's look at the next one. Abby, Davina, and Tembi all went to lunch. Their bill was $48.39. If they split it evenly, how much did each person pay? So I have Abby, Davina, and Tembi. That's 3 people went to lunch. So whatever is being split up goes inside the box. Their lunch is being split up, their cost. $48.39, that's the cost of their total bill, goes inside the box. It's being split up. Abby, Davina, and Tembi, that is who is splitting and sharing the bill. So 3 divided by 4, it's 48.39 divided by 3, and this is how we would write that problem right here. So looking at this, I'm going to go through and divide. Make that decimal a little larger. I'm going to go divide this and see how much each person would pay. I'm going to go ahead and bring my decimal up because I don't want to forget about it in my answer. 3 into 4, that goes once. 3 times 1 is 3. Subtract and get 1. Bring down the 8. 3 into 18, that goes 6. 3 times 6 is 18. I'll subtract and get 0. Bring down the 3. 3 into 3, that goes once. 3 times 1 is 3. Subtract and get 0. I'll bring down the 9 because I'm not done yet. 3 into 9, that goes 3 times. 3 times 3 is 9. And I end up with 0. I end up with, oh, perfect, 0. No remainder. So $16.13 is how much each of the 3 friends is going to pay. Remember, whatever is being split up, the cost of the bill is being split up in this example. That goes inside the division box. All right. If you did it the other way and you try to do 48.39 into 3 and then try to add a decimal and zeros, wow, that would be a really, really difficult problem. Hopefully you realize that that is not how we're doing it. So the bill goes inside the division box. Now, let me scroll down a little bit. 1 second. Let's see, let's scroll down some. Now, we just have a bunch of division problems to solve. Right there. Get back over here. Let me give my previous work an erase. Out of the way. All right, now let's go through all these decimal problems. So, first one, adding decimals. Whenever I add decimals, the most important thing is that when I go and set up my problem, I have to make sure the decimals are lined up right on top of each other, just like this. They have to be in perfect line, okay? And then in my answer, the decimal is going to be in the exact same place, lined up perfectly still. So, looking at this is my problem. I'm adding these. Any blank spaces can get a 0. And I just get to go through and add. 0 plus 2 gives me 2. 8 plus 5 gives me 13. Whoops. 13, carry the 1. 3 plus 2 gives me 5. Plus 1 is 6. What does that do? It's not writing. Give that an erase. 1 second. There we go. I had 2. I had 13. Carry the 1. 5 and 6. Oh, there's my decimal. I had it down. And then 0 plus 1 is 1. I get 16.32. Great. Let's look at the next one. Now, this is a negative plus a negative. We remember that when we add 2 negative numbers, my answer is still going to be negative. So let me go and set this up. 9.1, 1.429. Notice how the decimals are lined up when I add. That's the most important thing. And then it would still be down here in my answer. Look, they're all perfectly in line with each other. Now these are both negatives. You could write the negative next to the numbers if you want, but instead I usually do this. I always add the negative down here with my answer. That way I don't forget about it. So any empty spaces get a 0. So now we're adding these two negative numbers, which is great. 0 plus 9 gives me 9. 0 plus 2 gives me 2. 1 plus 4 gives me 5. 9 plus 1 gives me 10. And I get negative 10.529. Excellent. Let's look at the next one. This is where things get a little more complicated, and we have to really be careful about the signs in our problem. So I have 6.17 plus negative 9.5. Now, this is an addition problem. So because of that, my first instinct is to try and go set it up like this, plus 9.50. It's what I did with the last two problems. However, looking at this problem, I have to remember that whenever I have different signs, I have a positive number plus a negative number. Whenever I have different signs, I'm not really going to be adding. I'm really going to be subtracting. Different signs means you subtract. And we'll keep the sign of the larger number, just like with integers. Same thing still applies. Now, what's tricky here is that I'm not just going to put the first number that appeared in the problem on the top. I have to put the larger number on the top. Whichever number has a greater absolute value is the real technical rule, or whichever number is larger, excluding the signs. So 6.17 and negative 9.5. Whatever sign I would keep in my answer, because we always keep the sign of the larger, I'm going to make sure that number goes on top. This negative 9.5, that's the larger number. I know my answer is going to be negative. I'm going to put that number on the top. Okay? 6.17. I'm going to line that up. And now, because this problem has different signs, I'm not really going to add them. I'm really going to subtract them. If you try to do it the other way and set it up like this, 6.17 minus 9.50, you would get 7, borrow over here, 11 minus 5 is 6, 5 minus 9. We can't do 5 minus 9. Some kids try to subtract up. 9 minus 5, but whoa, we don't ever do that. We don't subtract up. We always have to go top, subtracting the bottom. This doesn't work, so hopefully you would recognize that you set it up wrong, okay? So, looking at this, I set it up like this. 9.5 minus 6.17, empty spaces get a 0, and then I'm going to go subtract because remember their signs are different. So 0 minus 7 I can't do. I'll borrow from the 5. That becomes a 4. This becomes a 10. 10 minus 7 is 3. 4 minus 1 is 3. 9 minus 6 is 3. Well, I'll bring the decimal straight down because when we add or subtract, the decimals have to be in line with each other. And I know I'm going to keep the sign of the larger number, and in this case, it's the negative. So negative 3.33 is what I'm looking for there. All right. Now, I'm going to stop that video and come back and one more. I guess we'll have to do a part 4 just to fit it in for the sake of time. And that's okay. So I'm going to stop the video right there. I'll see you guys in the next part.